This is a review of the Matters quizzes that we did at the beginning of the year. So looking at these shapes, you may remember these. We had shapes that represent different kinds of matter division. So shapes that were only elements would be shapes that have only one kind of atom, or boxes that contain only one kind of atom. So box A would qualify for that, as these circles are all the same. Box B would not qualify. Box C would qualify because they're all the same. But in box B, you see we have atom, one kind of atom here, another kind of atom here, and then we have a compound. We're looking for only elements, so elements only have one kind of atom. So the answer would either be box A, box C, or box F. And box F works because although they are diatomic, the atoms are the same. So there's still only one kind of atom in box F. So the answer here would be A, C, F. A heterogeneous mixture of elements and compounds would be box B. You have element, and a compound here because that's two atoms joined together chemically as a compound. So the answer there would be B. Now I'm going to go back to number 1 for a minute. I noticed as I was going through just a second ago that box G also would qualify as one kind of atom because you have a single atom here and you have a diatomic element here, but those are the same kind, so it could also have been G. Only compounds. Compounds are atoms that are bonded together, so they have to be different kinds of atoms. So this box would work, box H would work. Box I contains only compounds, it looks like. One kind of compound, different kind of compound, but all compounds. Box E works. Box F does not work because those are the same kind of atom. Box D works. And these are either elements or a mixture of elements and compounds, so those don't work. So only compounds would be box D, box E, box H, and box I. Mixtures. Mixtures contain two different identities. So that's a mixture because there's two different kinds of compounds. This is a mixture because there are two different kinds of elements. This is a mixture because there are compounds and elements that are different. The others are all pure substances, the other boxes. So a mixture would be either B or G or I. A pure substance is everything is not a mixture, it's a pure substance. So that would be A and C. And D would be a pure substance because there's only one identity. E is only one identity. F is only one identity. And H is only one identity. So D, E, F, H. 5 molecules. 5 molecules would need to have 5 molecules in it. So this one qualifies. This box qualifies. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it looks like D, E, F, H, I all have 5 molecules. Only a diatomic element, that is only diatomic, would be, let's see here, diatomic. That one is not a diatomic element. That one is a diatomic, and that one's diatomic, but it's not an element because the atoms are different. So the only one that qualifies as just a diatomic element would be box F. 8 particles would be something with 8 particles in it. So that has 8 particles, says 8 particles right there. 1, 2, 3, 4, 5, 6, 7, 8. This one has 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. That one doesn't work. 1, 2, 3, 4, 5, 6, 7, 8. So A or B both have 8 particles, and those are the only ones. 5 particles would be this one, 1, 2, 3, 4, 5. This one, 1, 2, 3, 4, 5. This one, 1, 2, 3, 4, 5. Or here, 1, 2, 3, 4, 5. Or here, 1, 2, 3, 4, 5. This one has 1, 2, 3, 4, 5, 6. So that one doesn't work. So it looks like it's D, E, F, H, I. 5 particles making up made of 20 atoms. Well, if you go back to that, you have 5, 10, 15, let's see, 5 particles, 1, 2, 3, 4, 5. There's 4 particles, 4, so it'll be 4, 8, 12, 16, 20. Here's another one, 4, 8, 12, 16, 20. I believe that's it. So it would be either D or H. D or H. Something that contains only molecules could be not that one because that has an element. Could be this one, could be this one because there's no plain elements there, no plain atoms, I should say. This one is an element, but it still contains all molecules. This one contains all molecules. That one contains all molecules. This one contains some molecules, but not all, so it doesn't qualify. So we're looking at D, and these are only elements, A and C. So we're looking at D, E, F, H, I. And then a mixture of elements would be 2 different kinds of elements, so that would be one of those, would be a different kinds of elements, because that's an element, and that's a diatomic element. And that's the only one that is just a mixture of only elements. So you need 2 different kinds of elements to have a mixture of elements. And what was that one? That was box G. All right, 2 substances evenly mixed would be, the best answer there would have to be a solution. And the reason for that is that if they're evenly mixed or homogeneous, and the only one of these 3 particles is homogeneous. You remember that for these particles, those had small particles, colloids had medium particles that would scatter light. Suspension has huge particles that settle when they stand. Okay, contains particles that are too small to settle out but too big to mix evenly would be a colloid. A homogeneous mixture goes back to number 13 to be a solution. Oops. Contain particles that scatter light but do not settle to the bottom of the container. That'd be a colloid. Misspelled colloid up there. Contain particles that scatter light and do fall to the bottom of the container. That'd be the bigger particles, so that would be a suspension. 2 or more identities, all of them, because all of these are mixtures. A glass of Kool-Aid would not scatter light because the Kool-Aid is very evenly mixed, it's homogeneous, so it would be a solution. And then shaving cream would be particle size that's in the middle, or intermediate particle size. The particles don't settle in shaving cream. So that would be a colloid. And that's a little review of the matter test that we did earlier this year.